Hello and welcome back at the FinetLink channel. As we launched at the last video, we are studying now for the second module of the CCNA with switching, routing and wireless essential. And now we are with the first module with the basic configuration, where you as a network administrator, we need detailed control of the device in your network. With this means precisely configuring switches and routers so that your network does what you want it to do for you. And in this module, which will be in two parts, we will configure device using security best practice. And the topics that we will see here will be how to configure initial setting on a Cisco switch, how to configure switch ports to meet network requirements. We will configure basic setting on secure management access on a switch. We will see even the configuration on a router to route between two directly connected networks using the command line, and after we will do all this kind of configuration, we will verify connectivity between two networks that are directly connected to a router. And before we can go and configure a switch, what we will need is to turn it on and allow it to go through the 5 steps of boot sequence. And here in this slide, we will go through these steps where the Cisco switch, when it is powered on, it goes through the following steps at the boot sequence, where the first step is when the switch loads a power on self-test known as post program stored in ROM memory. Post checks the CPU subsystem. It tests the CPU, DRAM, and the portion of the flash device that makes up the flash file system. And in the next step, the switch will load the bootloader software, where the bootloader is a small program stored in the ROM memory that is run immediately after post successfully completes. At the step 3, the bootloader performs low-level CPU initialization, where it will initialize the CPU registers, which control where physical memory is mapped, the quantity of the memory, and its speed. And then it will go to the 4th step, where the bootloader will initialize the flash file system on the system board. And finally, the bootloader will locate and load a default iOS operating system software image into memory and gives control of the switch over to the iOS. With the switch attempts to automatically boot by using information in the boot environment variable. If the variable is not set, the switch attempts to load and execute the first executable file it can find. And if we are analyzing the Catalyst 2960 series of switches, the image file is normally contained in a directory that has the same name as the image file, executing by .bin file extension. The iOS operating system then initializes the interface using the Cisco iOS commands found in the startup configuration file. The boot environment variable is set using the boot system global configuration mode command. You will see that the iOS is located in a distinct folder and the folder path is specified. When we use the command show boot to see the current iOS boot file, is set to. So this will be the command when we use in the global configuration mode to boot the environment variable. And as you can see, we will define each part of the boot system command. It will be the main command, it will be the storage device, and then the path to the file system, and the last one will be the iOS file name. The Cisco Catalyst switches have several status LED indicator lights. You can use the switch LED to quickly monitor switch activity and performance. Switches of different models and feature sets will have different LEDs, and their placement on the front panel of the switch may also vary. But it is important to know which end of this slide specify for. So here in this slide it is shown the switch LED on the mode button for a Cisco Catalyst 2960 switch. The mode button is used to toggle through the port status, port duplex, port speed, and if supported, even the power over Ethernet. And in the slide, it will be number 7. It will be this button, is the mode button. And we will see what will do all these LED indicators from 1 to 6. The first one, it stands for the system LED. That's why it's called the SYST. Shows whether the system is receiving power and is functioning properly. If the LED is off, it means that the system is not powered on, and if the LED is green, the system is operating normally. If the LED is amber, the system is receiving power but is not functioning properly. And the second light stands for Redundant Power System, or SRPS LED. It shows the RPS status. If the LED is off, the redundant power system is off or it's not properly connected. And if the LED is green, the redundant power system is connected and ready to provide backup power. If the LED is blinking green, it means that it's connected but is unavailable because it is providing power to another device. If the LED is amber, it means that the redundant power system is in standing mode or in a fault condition. If the LED is blinking in amber, it means that the internal power supply in the switch has failed and the RPS, redundant power system, is providing power. The third light stands for port status LED. Indicates that the port status mode is selected when the LED is green. This is the default mode. When selected, the port LED will display color with different meaning. If the LED is off, there is no link or the port has administratively shut down. If the LED is green, a link is present. If the LED is blinking in green, there is activity and the port is sending or receiving data. If the LED is altering green amber, there is a link fault. If the LED is amber, the port is blocked to ensure that a loop does not exist in the forwarding domain and it's not forwarding data. And typically this port will remain in this state for first 30 seconds after being activated. If the LED is blinking amber, the port is blocked to prevent a possible loop in the forwarding domain. And the fourth LED will be the LED for the port duplex LED. indicate that the port duplex mode is selected when the LED is green. When selected, port LED are in duplex mode. If the port LED is green, the port is in full duplex mode. And the fifth LED is about the port speed LED. Indicate that the port speed mode is selected. When selected, the port LED will display colors with different meaning. If the LED is off, the port is operating at 10 megabits per second. If it's green, it means that it's operating at 100 megabits per second. If it is blinking in green, the port is operating at 1000 megabits per second. The sixth LED will be about the power over Ethernet mode LED. If this is supported, we will have even the LED for this, and it will be presented at the switch. If the LED is off, it indicates the power over Ethernet mode is not selected and that none of the ports has been denied power or placed in a fault condition. If it's blinking in amber, the power over Ethernet mode is not selected, but at least one of the ports has been denied power or has a power over Ethernet fault. If it's green, it indicates that the power over Ethernet mode is selected and the port LEDs will display colors with different meaning. If it's off, the LED is off, the power over Ethernet is off. If the port LED is green, the power over Ethernet is on. If the port LED is alternating green-amber, power over Ethernet is denied because providing power to the power device will exceed the switch power capacity. If it's blinking in amber, power over Ethernet is off because of a fault. If it is amber, it means the power over Ethernet for the port has been disabled. But the bootloader, we know that provides access into the switch if the operating system cannot be used because of a missing or damaged system file. The bootloader has a command line that provides access to the file stored in flash memory. The bootloader can be accessed through a console connection following these steps that are listed here in this slide. By default, the switch attempts to automatically boot by using information in the boot environment variable. To view the path of the switch boot environment variable, you have to type the set command. And then you have to initialize the flash system using the flash init command to view the current files in the flash as it is shown here in this output. After Flash has finished initializing, you can enter dir flash command to view the directories and files in Flash as it is shown in this output. By entering the boot equal flash command to change the boot environment variable path the switch used to load the new iOS in Flash. And to verify the new boot environment variable, you have to issue the set command again, and you have to load the new iOS type by using the boot command without any argument. And these commands are shown here. The bootloader commands support initializing Flash, formatting Flash, installing a new iOS, changing the boot environment variable, and recovery of lost or forgotten password. So after we have turned on the switch, we have to prepare a switch for remote management access. The switch must have a virtual interface that is called as an SVI, where we have to configure an IP address IPv4 and a subnet mask, or an IPv6 address and a prefix length for IPv6 network, depending on what kind of network we are. The SVI, which stands for Switch Virtual Interface, is a virtual interface and not a physical port on the switch. You have to keep in mind that to manage the switch from a remote network, the switch must be configured with a default gateway. And this is very similar to configuring the IP address information on a host device. And here in this figure, there is a switch, a router, and this is all the information that we have to configure on a switch. And to do that, we have to connect the switch with the computer with a console cable plugged in the console port of the switch and the console port of the computer and the devices. By default, the switch is configured to have its management control through a VLAN 1. All ports by default are assigned to this VLAN. And for the security purpose, it is considered a best practice to use a VLAN other than VLAN 1 for the management VLAN. And here in the example for management VLAN, we are using the VLAN 99. And to configure the switch management access, we have to go through 3 steps. And the first step is configuring the management interface, where for the VLAN interface configuration mode, you have to enter for IPv4 networks, address and the subnet mask that should be applied to the management SVI of the switch, and even the IPv6 address and the prefix length. And these are shown here in this table. To configure the SVI, the switch virtual interface, what you have to do, you have to enter at the global configuration mode, and after that you have to enter in the interface configuration mode of the SVI, which in this case is the VLAN 99. So it means that you have to enter in this interface, and after you will be here, you will see that by the prompt, and you will be able to configure the management interface IPv4 for IPv4 network, where you will configure the address and the subnet mask, and for the IPv6 networks you will be able to configure the address and the prefix length. After that, you have to enable the management interface. To do that, you have to use the no shutdown command. And after you have done all this configuration, you have to return to privileged access mode. And to do that, you can do only by entering the end command, which means that you are changing the level on the configuration mode. And after you will be in the privileged access mode, you have to save your configuration by using the copy running config and the startup config, which means that you are saving the configuration at the startup config. At the second step, you will configure the default gateway. To do so, again, you have to be at the global configuration mode. But before we go there, you have to know that the importance of configuring a default gateway is so you will be able to manage the switch remotely from networks that are not directly connected with the switch. So for configuring that, you have to enter at the global configuration mode by using the configure terminal command, and then when you will be in this level, just configure the default gateway of the switch as using the command IP default gateway, and then enter the default gateway. Then you have to return to the privileged access mode, so you have to change level by using the end command, And when you be at the privileged access mode, you have to save your configuration by using the copy running config to the startup config. And at the last step is to verify configuration. And you can do this by using the show IP interface brief for the IPv4 networks and show IPv6 interface brief for IPv6 network. And the output, you will confirm that interface VLAN 9 has been configured with an IPv4 address, as you can see here, and with IPv6 address as it is shown here. At the output, it is shown that actually for the moment the VLAN is down. This means that there is no port assigned to this VLAN and there is no cable connected to this port, so there is no connection. When we try to configure the switches, what we have to configure there is to configure the duplexing, the speed, and the Auto-MDIX. When you try to configure the duplex communication, first you have to know that the port of the switch can be configured independently for different needs. You will learn to configure switch port, how to verify the configuration, common errors, and how to troubleshoot switch configuration issues. The full duplex communication increases bandwidth efficiency by allowing both ends of connection to transmit and receive data simultaneously. This is also known as bidirectional communication and requires microsegmentation. A microsegmented LAN is created when a switch port has only one device connected and is operated in full duplex mode. There is no collision domain associated with a switch port operating in full duplex mode. But unlike the full duplex communication, we have even half duplex communication, which is unidirectional. This kind of communication creates performance issues because the data can flow in only one direction at a time, and often resulting in collision. Half duplex connections are typically seen in older hardware such as hubs, but this has been replaced with switches that operate by default in full duplex communication. A gigabit Ethernet and 10 gigabit network interface card require full duplex connection to operate in full duplex mode. The collision detection circuit on the network interface card is disabled. Full duplex offers 100% efficiency in both directions, transmitting and receiving. And how you can configure the switch port for the duplex mode. Switch port can be manually configured with specific duplex and speed setting. We use the duplex interface configuration mode command to manually specify the duplex mode of a switch port, and we use the speed interface configuration mode command to manually specify the speed. So let's get an example, and let's see that we have this network and we have two switches that are connected together with a link, and each one is connected with fast Ethernet 01. And we want to configure the duplexity, the mode duplexity of the switches as full duplex mode, and we want that both speeds to operate with the same speed of transmitting and receiving data as 100 megabit per second. Here in this table, it is listed how we can configure those duplex and speed in the interface, but it will be the same even for the switch 2. The only changes is that the host name. So you can do the same configuration. So first of all, you have to be at the global configuration mode, and then you have to enter at the interface configuration mode by choosing the interface that you want to configure. In this case, it's Fast Ethernet 01. And after you will be in this interface, you can configure the duplexity, duplex full, by using this command. And you can configure even the interface speed by using the command speed, and then the speed of transmitting and receiving as 100 in this case, 100 megabit. Then you have to return to privileged access mode, which means you have to change level by using the AND command. And when you be at the privileged access mode, you have to save your running configuration to the startup config. The same will be even for the switch 2. The default setting for both duplex and speed for switch port is auto. The 10, 100 and 1000 port operates in either half or full duplex mode when they are set to 10 or 100 megabits, and operate only in full duplex mode when it is set to 1000 megabit per second or 1 gigabit per second. Auto negotiation is useful when the speed and duplex setting of the device connecting to the port are unknown or may change. When connecting to known device, such as server, dedicated workstation, or network device, a best practice is to manually set the speed and duplex setting. When troubleshooting switchport issue, it is important that duplex and the speed setting should be checked in case we have mismatched setting for the duplex mode and the speed of switchport that can cause connectivity issues. Until recently, certain cable types as straight-through or crossover were required when connecting devices. Switch-to-switch or switch-to-router connection require using different Ethernet cables. By using the automatic medium-dependent interface crossover as Auto-MDIX, this is a feature that on interface eliminates this problem. When this feature is enabled, so when Auto-MDIX is enabled, the interface automatically detects the required cable connection type, straight-through or crossover, and configure the connection appropriately. And when connecting to switch without this feature, without the automatic medium-dependent interface crossover, straight-through cables must be used to connect two devices such as server, workstation, or routers, and crossover cable must be used to connect to other switches or repeaters. With the Auto-MDIX enabled, either type of cable can be used to connect to other devices, and the interface automatically adjusts to communicate successfully. We use the command MDIX in the interface configuration mode to enable this feature, and it is shown in this slide. So we have to go at an interface that will be connected, and then you have to enter the MDIX auto, which means that you are using this feature to automatically adjust the communication successfully. To examine the Auto-MDIX setting for a specific interface, you have to use the Show Controller Ethernet Controller command with the PHY keyword, phi keyword, and to limit the output to lines, we have to include a filter by using the include MDIX command. And it is shown here in this example. After you have configured the switch, it is important to verify the configuration that you have done. So to do the verification on the switch, you may use different kind of commands that are listed here in this slide, and each command display different kind of information. Depending on those commands, when you need to verify switchboard configuration, we use the show running config command and can be used to verify that the switch has been correctly configured. And for the sample, you may be able to see some important information as it is shown here when we are getting information at the switch one that we configured 2 slides or 3 slides before. As you can see, we have information that the fast Ethernet 018 is configured with the management VLAN 99, which means that this port is assigned to this VLAN in the access mode, and the VLAN 99 is configured with an IPv4 address and the subnet mask, and even with an IPv6 address and the prefix length. In this switch, we even have a default gateway that it is configured. The show interface command is another commonly used command where we display the status and static information on the network interface of the switch. The show interface command is frequently used when configure and monitor network devices. If we use the show interface and we will specify which interface we want to see, we indicate that the fast Ethernet 018 in this case will show information, and by this we are able to see that the interface is up, which means that it is operational. Further down, the output shows that the duplex is full and the speed is 100 megabit per second here. You can get many different information by using the command show interface, which is useful for detecting common media issues. One of the most important parts of this output is the display of the line and data link protocol status as it is shown here, which means that we are standing for this, the first 3 lines. The first parameter, it says that the fast Ethernet 018 is up, which refers to the hardware layer and indicates whether the interface is receiving a carrier detect signal, and the line second parameter, which is the line protocol, it's up, refers to the data link layer and indicates whether the data link layer protocol keeps alive or being received. Based on the output of the show interface command, we can have different kind of problems. If the interface is up but the line protocol is down, there may be a problem. There could be an encapsulation type mismatch. The interface on the other end could be error disabled, or there could be a hardware problem. If the line protocol is down and the interface is down, a cable is not attached, or some other interface problem exists. For example, in a back-to-back connection, the other end of the connection may be administratively down. If the interface is administratively down, it has been manually disabled by using the shutdown command in the active configuration. The show interface command output displays counters and statistics for the fast Ethernet 018 as are highlighted here with orange. And there are some media errors that serve enough to cause the circuit to fail, but they can cause even network performance issue. We have input errors, which is the total number of errors. It includes runs, giants, no buffer, cycle redundancy check, frame overrun, and ignored counts. We have runt, which are for frames that are discarded because they are smaller than the minimum frame size for the medium. And we know that the Ethernet frame is less than 64 bytes and it's considered a run. We have giant frames, which mean that are frames that are discarded because they exceed the maximum frame size for the medium, and we know that the maximum size is 1518 bytes, and if that bigger than that, the frames are considered giants. We have the cycle redundancy check, which are errors generated when the calculated checksum is not the same as the checksum received. We have even output errors, where is the sum of all errors that prevented the final transmission of datagram out of the interface that is being examined. We have here collision and late collisions, where collision are numbers of messages retransmitted because of an Ethernet collision, and late collision occurs after 518 bits of the frame has been transmitted. And depending on those errors, we have interface input errors and interface output errors. The interface input errors is the sum of all errors in datagram that were received on the interface being examined. This includes runs, giants, cycle redundancy check, no buffer, frame overrun, and ignored counts. The reported input errors from the show interface command, as we saw at the slide before, included the runt frames, which are Ethernet frames that are shorter than 64 bytes, which is the minimum allowed length of called runs, malfunctioning of network interface card are the usual cause of excessive runt frames, but they can also be caused by collisions. We have giant Ethernet frames that are larger than the maximum allowed size, and these frames are called giants. We have the errors of cycle redundancy check when on Ethernet and serial interface. These errors usually indicate a media or cable error. Common causes include electrical interference, loose or damaged connection, or incorrect cabling. If you see many of those errors, there is too much noise on the link and you should inspect the cable. You should also search for and eliminate the noise sources. And as of the output errors, as we saw at the show interfaces command, is the sum of all errors that prevented the final transmission of datagram out the interface that being examined. It includes the collision and late collision, as we mentioned, where the collision in half duplex operating are normal. However, you should never see collision on interface configured for full duplex communication. A late collision refers to a collision that occurs after 512 bits of the frame that have been transmitted. Excessive cable length are the most common causes of late collisions. Another common cause is duplex misconfiguration, where you could have one end of connection configured for a full duplex and the other for half duplex. That's an example. You would see late collision on the interface that is configured for half duplex. In that case, you must configure the same duplex setting on both ends. A properly designed and configured network should never have late collisions. And when you have to troubleshoot your network, most issues that affected a switch network are encountered during the original implementation. Theoretically, after it is installed, a network continues to operate without problem, but by the time cabling gets damaged, configurations change, and new devices are connected to the switch that require switch configuration changes. So in this case, you have to maintain and troubleshoot the network infrastructure. To troubleshoot scenarios involving no connection or bad connection between a switch and other device, you have to go through general process, and these processes are shown here in this slide. When you have to perform the command show interface, and by the information that you will get there, you will see if the internet is up or it's down. If the interface is down, you have to check to make sure that the proper cabling are being used. You have to check the cable and connectors for damage. If a bad or incorrect cable is suspected, replace that cable. If the interface is still down, the problem may be due to a mismatch in speed setting, and the speed of an interface is typically auto-negotiated. But even if it is manually applied to one interface, the connecting interface should auto-negotiate accordingly. If a speed mismatch does occur through misconfiguration or because of a hardware or software issue, then you may result in interface going down. In this case, you manually have to set the same speed on both connections and if the problem is suspected. And what happens if the interface is up? By using this show interface command, you have to check for indication of excessive noise. Indications may include an increase in the counters for runs, giant, and cycle redundancy check errors. If there is excessive noise, first find and remove the source of the noise if it is possible. Also, what you have to do is to verify that the cable does not exceed the maximum cable length and check the type of cable that is used. If the noise is not an issue, check for excessive collision. If there are collision or late collision, verify the duplex setting of both ends of connection. Much like the speed setting and the duplex setting are usually auto-negotiated. If there does appear to be a duplex mismatch, you have to manually set the duplex to full on both ends of the connection. And if the problem is solved, yes, that's okay. But if it is not solved, you have to document the work done and escalate the issue to the proper site. In both cases, you have to document everything you have done for further investigation if that would be the same problem. And here in this slide, there is an example of how to configure switch ports. And we are at the switch 1. We are trying to configure the fast Ethernet 01 interface. And for this interface, we are configuring the duplexity, speed of transmitting and receiving data, and the Auto-MDIX for detecting the type of cables for transmitting and receiving, and then we have to save the configuration to environment at the startup config. So to do so, you will be able to enter the global configuration mode, enter at the proper interface, use the duplex auto command, speed auto, MDIX auto command for configuring the duplexity, speed, and the MDIX auto configuration, and then you have to be at the privilege exit mode by using the end command, and here in this level you have to save your configuration, the running configuration, to the startup config. And that was all about the first part of basic configuration. See you to the next session, and those who are new at this channel, do not forget to subscribe and hit the notification button for the new videos that will be uploaded. And thank you for being with us. See you to the next session.